Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. If you really like my teaching, my efforts, please press the like button, share the videos with your friends, subscribe to my channel, and also press the bell button to get the regular updates. In this video, I want to discuss few fields in the TCP header such as checksum and also options. So first let me discuss about the checksum field in the TCP header. Okay, we have a checksum field which will be useful for error detection. We have already discussed various error detection strategies and error correction strategies. Such as error detection strategies, what are the things we have discussed? We have discussed about even parity, odd parity, CRC and checksum. And in error correction, I have already discussed about the Hamming code mechanism. So I hope you have watched those videos. So in this video, I will not discuss how we will perform the checksum. Okay, already I have discussed how we will perform the checksum by using the ones complement addition and ones complement. Am I right or wrong? So again, I will not discuss in detail about what is checksum, but what will happen in the TCP checksum field I will discuss. So TCP checksum field is a 16-bit number. Am I right or wrong? If you see the TCP header format, you will see that TCP checksum which is a 16-bit. Now when it comes to the IPv4, even in IPv4 also we have a checksum. But in the IPv4 checksum, we have computed the checksum for what? We have header and data, but however, we have computed the checksum for only header. Why we have not computed the checksum for data? Because if you see that the data is very large, am I right or wrong? But another thing is that in IP, whenever the IP header is going with the data, few fields will change such as TTL, am I right? Time to live value will change, and total length of the packet will change whenever you are doing the fragmentation. So those fields will frequently change. So if I add data to the checksum, then the router will have more burden to again compute the checksum for the data and also the header. So that's why in IPv4, whatever the 16-bit checksum is there, it is only useful for computing the checksum for header. But when it comes to the TCP, you will have the checksum, whatever the checksum we are doing in the TCP, which is a 16-bit, which is useful for header and also the data. This is very important. At the TCP, whatever the checksum we are doing, it is for the header and also for the data. Am I right or wrong? Now, we will discuss what is the advantage if I do the checksum for header and data. Now, if you see that the packet, whenever it is coming from the sender, it will come from the application layer, then it will come to the transport layer, then from the transport layer you will get to the network layer. Now at the transport layer you can use either TCP or UDP. Now we are discussing about the TCP. Once we have completed the entire videos or the concept related to TCP, then we will discuss about the UDP. So if you are using TCP, then obviously TCP has the TCP checksum. There you will compute the checksum for the TCP header and the data. This data will come from the application layer. Am I right or wrong? So for a segment, for each segment you will have a TCP header and the segment data. So that one will come to the IPv4. When it is coming, this entire part will come as a data, and for that one IPv4 header will be added. At the network layer, we are computing the checksum for this one. Am I right or wrong? In IPv4, when we are computing the checksum, we are computing for the header only. So we are computing the checksum for this one. At the transport layer, we are computing the checksum for this entire data, because this entire data is nothing but the TCP header plus data. So we are computing the checksum for IPv4 at the network layer. We are checking the checksum for the entire data at the transport layer. So we are doing the entire checksum. This one is a performing checksum, and even this one we have a checksum indirectly. I hope you have understood what is the TCP checksum. It will be useful for computing the checksum for TCP header and data. Complete information, it will check the checksum. So if any bit is modified, the receiver can able to identify with the help of checksum. I hope you have understood about the TCP checksum. If you still have any doubts related to checksum, you can ask me in the comment section. Now we will discuss about the options. So option field, when it comes to the option field, we have 0 bytes to 40 bytes. Am I right? The option field in the TCP header is from 0 bytes to maximum 40 bytes. If option field is 0 bytes, then the TCP header will be 20 bytes. If option field consists of 40 bytes, then the TCP header will go up to 60 bytes. So, based on the number of bytes in the option, the TCP header will vary from 20 bytes to 60 bytes. Now we will discuss where we will use this option field. We can use it for timestamp. We can use it for the window size extension. We can use it for padding also. Now let me discuss about timestamp, where we will use the options for the timestamp. Then we will discuss about the window size extension, and then for the padding. Now if you see that in TCP header, we have a sequence number which is a 32-bit. What is the use of sequence number? It is useful for us to uniquely identify any segment. Am I right or wrong? Let's take that as you have 32-bit sequence. So you have 2 power 32 sequence numbers will be there. From 0 to 2 power 32 minus 1 sequence numbers will be there. Am I right or wrong? So if you have these sequence numbers, and for each byte you need to use a sequence number. Will you accept with me or not? Because it is a byte stream protocol. Each byte will consume one sequence number. Am I right? Even in the earlier examples when I am discussing about the TCP connection establishment, I said that if you are sending the TCP of 100 bytes, let's take that from 100 byte to 199 byte you are sending, then the sequence number will consist of 100. Next time whenever you are sending, the sequence number will go to 200, because 900 bytes you have consumed for transferring the data. So meaning is that you have consumed 100 sequence numbers. So each byte will consume one sequence number, and also for connection establishment we are using the sequence numbers, and for the connection terminations we are using the sequence number. Suppose let's take that you want to send a data size, means a segment of 2 power 32 greater than 2 power 32. Then what will happen? Meaning is that you have to send a segment whose size is greater than 2 power 32. Then each byte, if you allocate a sequence number, then all the sequence numbers will be finished to 2 power 32 bytes. Then whatever the new bytes you are generating, what you will do? Again you will go for the 0. But this 0 and this 0, how you can differentiate? Are you able to understand it or not? You have 0, 0, 0. For 0th byte you are assigning a sequence number all zeros. Then 2 power 32 minus 1 byte you will allocate all 31 bits. Then once it is finished, then 2 power 32 byte if you want to assign, then again what you will do? Again you will assign the 0. Now there is a confusion. This 0 and this 0, how we can differentiate? Now how it will be differentiated is that once all ones are generated, are you able to follow it or not? All zeros, then next one you will have 0, 0, 0, 0 to 1. Next time you will have 0, 0, 0, 0. Next sequence will be 1, 0, then 1, 1, like that all ones will be there. So if I keep again all zeros, then it will also be sequence number 0 and this will also be sequence number 0. How can you able to differentiate? There is a confusion. So what will happen is that once you generate all ones, next time when you are generating the next sequence number, it will be 132 zeros. Are you able to understand? Now, if you see that this one, we will call it as a timestamp. For this one, the timestamp will be 0, 32 zeros will be there. 32 zeros is the 32 sequence number will be there. Am I right? That is the 0th sequence number. But you have a timestamp. So, now if you see that the timestamp for this one is 0, all 32 zeros are there. This you can identify. And coming to this one, the timestamp is 1 and these are 32 zeros are there. So you can able to differentiate these two sequence numbers with the help of a timestamp. But now you can ask me, sir, where you will keep this value 1? Where I will keep? In the options field I will keep, because the sequence number is 32 bits only. So if I want to keep the 33rd bit, sequence bit will not permit me. Am I right? So this value I will keep it in the timestamp. Are you able to understand? So we will use it in the options field. In options field we can keep up to size of 40 bytes. So I'll keep this value. This one we will call it as a timestamp. Okay. Now let me discuss the next concept called window size extension. Now when we are discussing about the TCP connection establishment and data transfer, we discussed that for a flow control, sender and receiver will send the advertisement window. Am I right or wrong? It will send the advertisement window saying that this much window or this much buffer I have allocated for transferring or for receiving your information. Am I right or wrong? Let's take that sender and receiver is there. Okay, sender is transferring some data and obviously it will wait for the receiver to send the data. So the sender will keep a buffer that if receiver sends the data, it has to store the data for time being, and once it processes, it can send to the upper layers. Am I right? So it will say that to receive the information for you, I kept some 400 bytes of buffer. That information it will send in the advertisement window, or we have the window size. So there it will send the value 400. Then the receiver will understand that, okay, if I want to send the information to the sender, maximum all the segments concludingly, I can send 400 bytes. If I send more than that one, then the sender cannot receive the data more than 400 bytes, then the packet drops will happen or the segments will be lost. Are you able to understand it or not? So this is what the flow control. But what is the size of this one? If you see the TCP header, you have 16 bits only allocated for that one. Am I right or wrong? The 16 bits are allocated. So if you have a 16 bits, what is the maximum window size you can represent? 2 power 16 minus 1. Am I right or wrong? So 65,535 bytes only you can advertisement the window. But you want to advertise a window of, let's take that 2 MB. 2 MB you want to advertise. 2 MB is what? This is 2 power 20 and into 1, 2 power 21. So meaning is that you need a window size of 21 bits to advertise a window size of 2 MB. Will you accept with me or not? Because MB is nothing but 2 power 20 and into 2, so 2 power 21. So you need minimum 21 bits in the advertisement window or window size. But however, we have 16 bits only. Then using 16 bits, how can you represent a 21 bit number? It is not possible. So you need extra 5 bits. Those 5 bits you will take from the option field. That is what we will call it as window size extension. The first 16 bits you will keep it in the window size and the remaining 5 bits you will keep it in the options field. Are you able to understand? So this concept we will call it as window size extension, and already we have discussed about the timestamp. Now let me discuss about the padding. When it comes to the padding, where it will be useful? If you see that we have a field called header length in the TCP frame format, we have a field called header length whose value is only 4 bits. Okay, what is the use of this header length? It will say that what is the size of the TCP header. What is the maximum size of a TCP header can go? Up to 60 bytes. Will you agree with me or not? Minimum is 20 bytes. Maximum it can go up to 60 bytes. So what is the value should be there in the header length? It should have the binary representation of this value 60. Can you convert this one into binary number? 60, if I convert into binary number, I will have 30, 0, 15, 1, 2, 7s, I will have 1, okay, sorry, this is 0, sorry for it, okay, and 2, 3s, 1, 1, 1. So you have to represent it as 1, 1, 1, 0, 0. So you need minimum 6 bits to represent the header length as 4 bits. Because you have header length 4 bits, how you will represent a header length of 6 bits to represent the value 60? So 60 you need to represent. That is what the meaning of header length. Header length says that what is the size of the header. My header size is going to up to 60 bytes. That's what we have discussed, because minimum is the 20 bytes and option can go up to 40 bytes. So total 60 byte is there. So 60 bytes if I convert into binary number, I need minimum 6 bits. But how I will represent in 4 bits? Don't think that I will take these 2 bits and keep it in the padding, in the options. That is not the point. Some people may think that, sir, first 4 bits you keep it in the header length, such as 11, 00 you keep it, and in the option field you take 2 bits and keep it, this 11. No, that is not the point. Lot of people will think like that, but that is not the point. What we will do is that in the header length, we will divide the value 60 by 4. If I divide the actual header length divide by 4, what is the value I will get? 15. Can I represent the 15 in 4 bits? Yes. Easily I can represent 4 once. If I write in the binary number, then it is equivalent to decimal number 15. So I can represent. Okay, problem is solved. If I want to represent 20 bytes, 20 by 4. The header length is 20 bytes. I need to represent in the header length. So 20 by 4 is 5. So value 5 is what? 0, 1, 0, 1. This is the value. This value I will store in the header length. The problem is solved. But the problem is still not solved. Why it is not solved is that, let's take that the header length is 30 bytes. Okay. Are you able to understand? The header length is 30 bytes. 30 by 4. What is the value? 7.5. Can I represent 7.5 in 4 bits? Because it is a floating point number. We have already discussed how to represent the floating point numbers while I was discussing in the computer organization course. I request you to watch those videos related to the floating point representation, such as IEEE single precision and double precision. You cannot represent the 7.5 or a floating point number in 4 bits. Then what you have to do? Then some people will say that, sir, instead of 7.5, because we cannot represent, we will represent 7 only. 7 we can represent 0, 111. Problem is solved. Is the problem is solved? No. Why? If you take the header length as 7, 7 into 4 is equal to 28. Meaning is that first 28 bytes is the header. But what is the header length? First 30 bytes is the header. So what is happening? 2 bytes from the header, you are considering it as a data. That is the problem is happening. Are you able to understand it on? Okay, the problem is not solving if I take it as 7. Why can't I make it as 8? But if I make it as 8, 8 into 4 is 32. But actual size is 30 bytes only. So still the problem is not solved. Then the actual solution is for this one is that, what I will do is that for this 30 bytes, I will take 2 bytes as padding bits. I'll keep all zeros. That value I will keep it in the options. So it will become 32 bytes. Meaning is that actual header size is 30. Okay, but I need to make it divisible by 4. So that's what I will do is that I will take extra 2 bytes from the options field. I will make it as all zeros in the 2 bytes. Then the header length will become 32 bytes. 32 by 4 is equal to 8. I will represent 8 in the header length field in 4 bits as 1000. So this is the use of the padding in the options field. So I hope you have understood how I have done the TCP checksum and the options field such as timestamp, window size extension and padding. If you still have any doubts related to these two concepts, you feel free to ask me in the comment section. I will try to clear your doubts in less than 24 hours. Thank you for watching my video. Have a nice day.